Friends, I want to tell you something amazing about science. We are on the verge of entering a whole new era of scientific progress. The discoveries of this new era will be based on a fundamental innovation in the basis of scientific understanding. Science is fundamentally about induction. Induction is the process of drawing universal conclusions from limited observations. We do experiments in a lab, we develop a theory based on the experiments, and we believe somehow that this theory is going to hold for all situation scenarios that we have not seen before. It's really amazing that this works. Just to drive home how amazing this is, here is the Ingenuity, the helicopter built by NASA to fly on Mars. Humans have never done any significant scientific experiments on Mars about electricity, about aerodynamics, and yet our theories are able to work so well and be so general that this helicopter flies in the atmosphere of a different planet. What's more amazing is that all of the science we've done so far has been based on an extremely primitive idea about induction. This idea is basically by Karl Popper. And Popper says, what you should do is develop a theory, do a lot of experiments. If the theory always agrees with every experiment, it's probably true. Otherwise, it is false. Throw it away. Try again. And this is valid. This works, obviously. But it's extremely constraining because it disallows the notion of a statistical theory. We might want to have a theory that is correct 99% of the time. Popper's method of induction does not allow this. You might say, how can I say that Popper's induction is primitive? The reason is that we now have the real theory of induction. It was discovered in the second half of the 20th century. One of the leading lights of this research was a Russian mathematician named Vladimir Vapnik. Now that we have the real theory of induction, we can see that Popper's notion of induction that was used by all classical science was actually extremely primitive. And I'm actually going to tell you about what the real theory of induction says. Let's start by looking at this graph. We have a bunch of points. The gray points are our data samples. And we're trying to decide if we want to pick the straight line, drawn in red, or the complex curve, drawn in blue. I hope that most of us can intuitively see that because we have so few data points, in this case, we should select the straight line because it's simpler. We have that intuition. Now, what happens when we get more data? We go up to n equals 120 data points. And here, all of the new data points have fallen near the curve. Again, I hope that we have an intuition that suggests that now we have so much data that we're justified in selecting the curve. So the fact that we have more data means we can now use a more complex model. And we have that as intuition. The real theory of induction gives us a strong mathematical understanding of this intuition. The theory of induction relates the accuracy of the model with the complexity of the model, with the quantity of data that we have available, as well as the probability of generalization. And the most important point is that we now see that we can build complex models if we have enough data. That's the requirement. In classical science, we could never build complex models. We were always obsessed with making the theories as simple as possible because people did not understand the real theory of induction. Now that we have the real theory, we can build complex models if we have enough data. This was never understood before 1968. And just to drive home this idea, I have a little timeline here of some highlights in the history of science. We have these amazing researchers and physicists who made these incredible insights about relativity, about electricity, about the basics of force and motion. All of these insights happened before Vapnik and his coworkers discovered the theory of induction. So I believe that 1968 was an inflection point where we now have entered this new era of scientific progress. And I'm going to give you a taste of that. I'm going to talk about language modeling and a system called GPT-3 that was built by a company called OpenAI. Language modeling is basically about sentence completion. You have a series of words and you want to fill in the most appropriate blank in that sentence. Humans are very good at this. We can tell just by looking at the sentence that there's just a couple of words that can go in this blank. First of all, it has to be a noun. We know that based on grammar. Then we can also bring to bear a lot of world knowledge that suggests it's got to be a liquid, it's got to be something you can drink. As far as I can see, my strong guess is that the blank is the word beer. The man drank a large brown beer. Not a whole lot of other words can go in that blank. So language modeling is the process of building computer systems that can do this kind of fill in the blank task. GPT-3, which was released last year, is a huge language model. It's trained on an enormous quantity of text. And I want to extrapolate based on those graphs I showed you before. For n equals 12, we should select the straight line. For n equals 120, we can select a complex curve. Think about what happens when we get to n equals 12 trillion. Think about how amazingly complex and sophisticated this kind of model can be. Just to give you an example, here is a guy who has been suffering for decades based on a shoulder injury. He went to many doctors, they did tests and MRIs and all kinds of different experiments, and none of them could get the right diagnosis. Now, what he's done is he's typed in his symptoms into GPT-3. What he typed is in the bold letters, and you can see that he prompts GPT-3 to complete the sentence, which gives a diagnosis. And this is actually the correct diagnosis. A torn labrum is what he was actually suffering from. None of his doctors or therapists were able to figure that out. Toastmasters, I hope you've learned a little bit from this talk. I hope you're excited to move into the second half of science. We're going to do amazing scientific theories about biology, about neuroscience, about cosmology. And if you want something really basic, you can have a self-driving car. Thanks very much.